G'day comrade subscribers. So I thought we'd have a crack at powering it on today, see if we can, well, see if it works. Yeah. So I'll just take the plastic off first. Just getting stuck on the keyboard there. That slides off. I haven't screwed it back up, so everything comes off. So the keyboard could actually be a good candidate to be converted to a modern mechanical. Maybe there is maybe might be enough space, but the initial issues would be having to model this connector in KiCad and then actually obtaining said connector. Maybe have to probably from our friends in Ukraine. So you can see it's an SNP 5832. So it's I think 2 by 32. There should be, it's been a while since I looked at these. /95, like a 22, yeah, okay, so they're 2 rows, so 32 pins, 2 rows, but it's an SNP 58, I think. Is that a 58? I think that's how I read it. So we need to get one of those for any replacement board that we build. Anyway, we're not worrying about the keyboard today. I'm going to make sure it works first. Right, so 2 issues. Power supply. This didn't come with a block Britannia power supply, so I'm going to have to, well, probably, I don't know, might see if I can do some pin headers or something in there perhaps. But yeah, we need 3 voltages, so plus 12 volts, plus minus 5 volts and ground. So I've got a Meanwell with a 5-pin DIN to do that. I don't have any 5-pin sockets. I've got a 7-pin socket, but that's no problem. We can very easily convert that to 5-pin. So I'll use that initially to hook it up, to power it on. And then the second issue is that it's got RF out, so it'll be CCAM. That's not a problem with modern displays, but it's RF modulated, which I can't really use. So we'll pull apart the can. And probably, no, I don't think, there won't be anything on the top, so the wiring will be probably here, how the signal gets into the can. So could be that one, or it could be this trace here, or that could be actually to the, yeah, all right. So I reckon that it could be this trace here. That's the signal in, baseband signal in that we want to hook into. So we'll have a look at that, and then probably have a look at Sergey's. So this is Sergey's modern Radio 86RK, and this is his basic composite out, well, it's not composite, it's baseband video out circuit. So we can maybe do something similar, see how this works. But first, let's sort out the power. Got the manual, and there is, I haven't bound it properly yet, so bear with me. That's the UHF modulator. Oh, talking about the SS and US keys, it actually does, if you have a look in, that's the keyboard schematic. If you have a look in the, here, this is the character set and how to get the keys. You can see here if you push US and D, you get graphic symbols. So US can be used for graphic symbols, and then the SS down here, SS, can be used to get the punctuation symbols. So like, for example, these are above the number 1, 2, 3 sort of thing. Anyway, the block Britannia schematic that has the pinout for the, that's the keyboard schematic. Let me find it. Oh, here we go. There's the block Britannia. And here's the schematic. So, pin 2 is 12 volts. Pin 1 is plus 5 volts. Pin 4 is negative 5 volts. And pin 3 is common.
Общий.
So, общий. Oh, anyway, whatever. Yep. And you can see on here very faintly, probably close up, you can see better than I can. You can actually see that is numbered. I'm just trying to see it through the... I'm going to have to use the loop. I'll be able to see it when I play it back. That's 3, that's 4, okay. And is that 1? Okay, yeah. So pin 1, pin 2, pin 3, pin 4. So... get my poker. So plus 5 volts, plus 12 volts, ground, and minus 5 volts. All right, let's go. This might work, not ideal, but I've just got a 2x2 pin header, so I've just chopped it off this. And it actually does seem that it will fit pretty nicely. So then I just connect my wires up to there. Obviously, it's not keyed, so I'm going to have to make sure I know which is which. But that seems to be a good temporary solution, so I don't have to take that off. Okay, first part is done. So that'll plug into the Meanwell power supply here, like so. And then we've got minus 5 ground, plus 12, plus 5 volts. So I'll just tidy this up, put some glued heat shrink over it, and then we'll sort out the UMPK end. Why didn't you guys tell me I was using a panel socket, not a cable inline socket? I wouldn't. I didn't even think. I did not even think, because I think I actually got 7-pin cable sockets. Not. I think I originally got this because I was thinking of seeing if I could replace this with a DIN socket. Anyway, whatever. I'm almost done with this one. So yeah, okay. That's why I'm using a panel socket, because I completely did not realise. I'm almost embarrassed to show this. That is terrible. I know. Again, I don't know why I was using a panel socket when I've got... Anyway, whatever. This is very temporary. And there we go. So we've got pin 1 I've marked with blue. So basically plus 5 volts pin 1, plus 12 volts pin 2, ground pin 3, and then negative 5 volts pin 4. So it should plug in like so, like that. Very, very temporary. I'll have to see if I can get some of these plugs out of Ukraine. Right, let's taken me long enough. Let's just see if we get the power on LED, or if we get any kind of, if we can change the roost lat LED as well. That means it'll kind of be working. Okay, plug it into the Meanwell power supply. Okay, I'm not sure how bright these LEDs are going to be. Power on. Alright, Vuckel's on. Roost went on then off. Okay, I'm not getting any response when I press the lat button. So it might not be working, although you hear a bit of a beep. Spros. Well, reset always works, doesn't it? Reset always works. Alright. I'm not confident that we're going to have that we've got a working machine. Well, or maybe the keyboard's just not very good. Alright, let's see if we can sort the video out then. Right, so I've taken the modulator can off and I've noticed that there is a very slight lip or rise on this side here. So, because I was assuming the signal in was coming from underneath. But yeah, there is a very, very slight difference in height. That means there are traces can go under here without being shorted. So, that means, by the way, look at the size of that crystal. Baby, look at that. That's a big one. Anyway, so it looks like, I zoomed in, so it looks like the signal, well, there'll be power coming in as well. Just move that resistor. So either this is power, but that's coming from the transistor. So I reckon that could be the signal in perhaps. And then we've got this, although this looks to be, okay. So there's two possibilities. There's this trace here that comes from a variable resistor or trim pot, I guess. Or we've got this trace here that comes from a transistor. But we do, I thought, yeah, we do actually have a very small schematic on the last page, I thought. There it is. Take that out. I don't know what use this is going to be. I found it. I think this is the video signal here coming out. I assume that's probably going into the modulator can. But we've got a variable resistor here, R22. Unfortunately, nothing's labelled on here. But we've got variable resistor there, resistor, transistor, and also we've got, I think this is the shift. I think this is the shift register, maybe 74198, which is, I think, this one up here. So I've got this up here, this is the character ROM, and this is the CRT controller. So I think those three there, we've got the ROM, we've got the shift register, and I think, yeah, and we've got the CRT controller there. So that's those three chips up in the corner. And then we've got the signal coming across to here via this resistor here into the modulator can. So I reckon that this trace here is our baseband signal, that there. So normally what I do is I disconnect the power from this so it doesn't interfere, or I just where does it go to next? It goes to an inductor. Maybe trace where it goes to. Oh, okay, looks like it goes to a transistor here. I could maybe cut the trace there, because I can always rejoin it. What's the easiest way of doing this? Although I do have my little tester here, a little baseband video where I can just tap it on actually and see if we get something out. Although if it's not working, we're not going to get anything, are we? All right, let me give that a try. All right, so there's no video output. I'm not getting a display on my LCD on my yo, but there is a signal. So let me just hook this up again. All right. Attach that to ground. So all I'm doing is I've tapped into the video signal. I've not disconnected the modulator. It's, you know, signal still going to the modulator, power still going to the modulator. So power on. Mind you, that's me holding it, so I'll try and wrap it around so I'm not interfering. Auto. Wait for it. Okay, so first thing I see is that there's a DC offset, which I know, oh shit. So it does look like there is a signal there, but there's a DC offset. So that's the first problem, I think. I don't really know if that's really a black and white signal though, is it? What are we, 1 volt per division. That's 2 volts per division. 1 volt per division. What am I trying to do here? So there is something. But yeah, there shouldn't be a DC offset, should there, for a start? So I'll show you what I've done. So all I've done at the moment is I've just tapped in, got this wire here to get the video signal out, but I haven't disconnected the video signal from the modulator circuit, nor have I disconnected the 5 volts in, which is that thick rail there. So yeah, might disconnect the power maybe. I might isolate it, yeah, might isolate it. So I just tried it with 100 nanofarads, 100 microfarads, but I think I had it polarity wrong. Didn't make any difference. But I had a look how Sergey has done his modern version compared to the original, and it is pretty close actually. On Sergey's one, we've got an additional input. So on the 8275, the CRT controller, we take the HRTC and VRTC, horizontal retrace and vertical retrace, out, whack it through there, invert it, and then that makes part of the output. But then he's got this additional RVV, so that's the reverse signal, so whether the text is reversed or not. So he's got that as an additional input, goes into here with the inverted output of the character. We've got the character ROM here and the shift register. So it's a little different. So basically this is the same. This is the same, the horizontal and vertical retrace, but he's got the additional reverse inverse text handling there as well. But otherwise we've just got one output coming from the shift register into here, and then he's got 75 ohms, so we're impedance matched, and then he's got a pair of capacitors here in parallel, 22 nano and then electrolytic 47 micro. So and then he's got 150 ohm between there and ground. So if you look on the original schematic, here we've got the horizontal and vertical retrace out of the 8275, I think NAND and inverted, coming in via resistor, and then we've got the output from the character ROM here going through the shift register, being inverted, resistor there into the transistor, and then we've got this resistor and the variable resistor, and then we've got the output going off. So I measured this, so this is 50 ohms and this is about 5 ohms at the moment, so it's about 55 ohms. not 75. So we've got 50 ohms here. This is the transistor here. We got, where is it? No, sorry. I think it's 50 ohms here. And then we've got about 4.65 ohms there going into here. So we could increase this variable resistor so that it's 75 ohms. Well, 25 ohms here, so we get 75 in total. So move it around a bit and we'll measure it. But otherwise, add these additional capacitors in to, I guess, get rid of the DC component of the signal. So I will try that as well. We've got 47 micro, and I'll get a 22 nano. And we'll try it out, see if that makes a difference. So I'll try that. The only difference is that I won't have the 150 ohms to ground. So I can add that next. That doesn't look too good. So this is what I've done. I've got the impedance about 75 ohms. I've added a 100 microfarad electrolytic again, and I've got 150 ohms to ground. Very similar to what the Radio 86 or Sergey's has got. And I've also managed to get a proper printout of the relevant parts. So I'll have a quick look, because I'm not too sure that this is working. So there's two parts to the video output circuit on the radio. So we've got this horizontal retrace, vertical retrace coming out of the 8275. That goes into here, D6, which is a K115 LP5. And then it goes into an inverter, which is a 155 LN1. And then it comes in here into our transistor and then out to the RF modulator. Now the actual data comes out of the shift register here, the 74198, and is inverted and then is added together here with the transistor, which is very similar to what the Radio 86RK does. So what does that mean? Let's just turn the power off. So there's the 8275, that's the CRT controller, that's our character ROM, that's our 74198, the shift register. So we're getting data out of here. Well, from here, shift register here, but here, vertical retrace and horizontal retrace is what, D11, so D11 is here, and that's D6 here. Okay, so let's have a look then. Let's have a look at the signal going into the transistor. Let's have a look at that. Not making much progress. Anyway, I found an error in the schematic. So this is listed as R19. There's two R19. So this is actually R18, which is R18 and R19, which is R18 there and R19. So this is the input to the transistor, which we see on here. So that's output from the shift register, so that's the character data, I guess. And then this is the horizontal and vertical retrace. So let's just check both of those. I have a feeling that there's one of the retraces isn't working. All right, let's check some signals then. So this is the input to the transistor. So this is the output from the shift register. So I think this is the character data. All right. So maybe this is okay, I guess. Okay. So that's the output from D11. So that's probably okay. All right. So the other way, coming from the CRT controller, so we've got, let's just coming out of D11 pin 6. D11 pin 6. Let's just move the ground. 1, 2, 3, 4, 5, 6. Okay, 1 volt per division. So that seems to be doing something as well, okay. But that is what, a NAND, or is it an AND of the horizontal retrace and the vertical retrace? So if we have a look at D6, the two inputs, okay. D6, okay, pin 4 is the horizontal retrace. 1, 2, 3, 4. Okay, so that's the horizontal retrace coming out of the 8275. And pin 5 is the vertical retrace. All right, it wasn't doing anything before. Now it's doing something. All right. That looks okay. So that's vertical, which we don't expect as much as horizontal. So that seems to be maybe working, all right. And then pin 6 is the output of both of those. Which is kind of what we would expect. Okay, and then it's inverted. D11, pin 5 is the input. 1, 2, 3, 4, 5. And then pin 6 is the output. So that's pretty much right, isn't it? Okay. And then pin 6 goes up via R19 and is combined with the character data. To give us that still doesn't look right, does it? That's 1 volt peak to peak. All right, that's with DC, and then this is via the. That's looking better than it was before. So you can see that's without that's going through the electrolytic. You can see we've got some DC there. And through the electrolytic we've lost the DC. But that still to me doesn't look like a proper video signal. Maybe it is, I don't know. That's the closest I've got so far. Just by connecting it before the electrolytic. Just kind of experimenting. Nothing there. Doesn't want anything now. Thought about it. Keeps thinking every time that no signal goes away briefly, that's, you know, you almost got something. I was getting close. Bugger. I was just setting up the camera because I was getting close. I thought I almost saw something. I was just adjusting the variable resistor. Almost had something. I just went. Okay. Well, it's not really exactly the most secure of connections. Alright, so that's minimum. That's minimum for the variable resistor. That's maximum. Come on. Then we need to power off again. I've got to go down to city tomorrow. All I want to do is just see if we can see the Radio 86 text from the boot, then we know the machine's working and we just need to sort out the video circuit. Might even be worth just replacing this transistor with a Western one and just copying Sergey's circuit, because we know that works. No, I think we're going to get it. I give up.